Hi guys, a couple years ago actually, let's see here, this was in November 20th, 2012, I uploaded a video where I was drawing out the schematics for the inversion of the glass sky. I call it the false vault of the sky explained. And I was saying what is happening is though, it's not a dome, okay? It just gives the illusion of a dome, okay? So we're in the concave ball, we're in the ball Earth. Okay, we have a glass sky above us. Now normally, the way refraction works is that if you're looking at a convex lens in the sky, it's going to shrink objects. However, there's a term called negative refraction. Well, let's just watch this video where I talk about it a little bit. I didn't mention negative refraction here in the video, but I was just saying how it creates this inversion. So let's just play that.
However, because the glass artifice creates this opposition and curvature, it's basically, you know, it actually is a convex ceiling to the sky, but it warps it, it turns it in, it inverts it, it makes it into a dome or a vault. That's what we think the sky is. So basically, this is the real.
Okay, so it gives an illusion of a dome. Okay, and that is because I believe it is creating negative refraction. So instead of shrinking things behind it, it actually is enlarging them and it's inverting the sky. Now I was just looking this up. Actually, I knew about this previously, but within the Libyan desert glass, there are traces of graphite. Let me find that really quick. Here we go. The silica glass also contains carbonaceous inclusions consisting of 5 to 50 nanometer thick polygonalized graphite ribbons that form closed structures up to 200 nanometers in diameter. So the graphite ribbons. Now, negative refraction, if you go to Wikipedia, you look up negative refraction, it will say negative refraction is a name for an electromagnetic phenomenon where light rays are refracted at an interface in the reverse sense to that normally expected. Such an effect can be obtained using a metamaterial, which has been designed to achieve a negative value for both electric permittivity and magnetic permeability. Now, metamaterial is a man-made material. Metamaterials are artificial materials engineered to have properties that have not yet been found in nature. However, graphite, this study right here says graphite, which is not a man-made material, it's actually a natural material, has been found to produce negative refraction under certain ultraviolet conditions. I'll find that for you right here. Negative refraction at deep ultraviolet frequency is monocrystalline graphite. Monocrystalline graphite. Using ellipsometry measurement of the equifrequency contour in the deep ultraviolet frequency region, typically 254 nanometers, obvious negative refraction was demonstrated in monocrystalline graphite for incident angles ranging from 20 to 70 degrees. This negative refraction is attributed to extremely strong anisotropy in the crystal structure of graphite, which gives the crystal indefinite permeability. So, you'll have this little graphic here where I show that I explain what I just read to you, okay? There are little ribbons, microscopic graphite ribbons within the glass that are creating a negative refraction in the sky. So it's actually inverting the sky to give you the illusion that the sky is a dome. So I can just go into Illustrator here. I'll show you really quick. I just made this graphic really quick. Here is the concave Earth, and you're standing on the inside surface. Okay, this thick black line is the surface of the Earth. And if I zoom in real close here, you know, I got an observer here, and this yellow line is the glass sky. Now, let me get the right layer here for you. Okay. Now normally, okay, these purple arrows normally That's a normal refraction. It would shrink objects from Earth's perspective. So if you're down here, if you're looking up into the sky, it's shrinking the heavenly objects, and it's giving the normal indications of normal refraction. However, because of the graphite ribbons within the glass sky, it is actually inverting the sky, so it's diverging outward toward you. And that's also why I believe we get the sun and moon illusion at the horizon. With this negative refraction, it simply just turns the convex dome inside out, and you get actually a greater refraction at the extremities here. Okay, the greater the incident angle, the greater the squishing and the greater refraction like that. And so this little blue area would be the apparent dome illusion, the dome illusion that you think is the sky. Negative refraction in glass creates the sky dome illusion. Okay, so light is bending within the Earth. If you're new to this phi ratio trajectory of vision is showing how light actually bends. It gives the illusion that you're living on a ball. And with this negative refraction of the glass sky, it inverts the heavens. Okay?
Interesting. Well, I got introduced to your model about maybe not long ago, a few days ago. Tell me about your model. If you want to tell me about your model, I'm open to listen.
Did you come across Widmanstatten patterns in octahedrites?
No, I'm familiar with platonic solids, Archimedean solids, and pretty much geometry. But no, I'm very interested to why you picked octahedrons for the center of your model, though.
I gotta share the screen here. Look at that. Isn't that wild? It's a slice of an octahedrite, meteorite. They all exhibit that Widmanstatten pattern. You won't find a rock like that on Earth. I mean, derived from Earth.
That's excellent.
You'd have to really conclude that their origin was octahedral. Came from a giant octahedron.
I don't know. I think the cube octahedron's more stable. Every single edge is the same distance from the corner to the center. It's the most stable.
Yeah, but the geometry doesn't. We don't see cube octahedral geometry in the Widmanstatten pattern. We see octahedral geometry.
Okay.
This is the Muonionalusta meteorite.
Did you say that this is the only mineral that's magnetic, or something like that?
No, well, the most magnetic mineral is magnetite, and magnetite's base crystal shape or habit is octahedral. They come in octahedrons.
I find that fascinating.
Yeah. So just picture, if you will, a giant octahedral magnet in the center of the concave Earth, bending the light, creating the magnetism.
Somebody's got to be creating it.
Stishovite was found in this particular octahedrite. A high-pressure polymorph of SiO2, extremely rare, and it was, they concluded it was due to some type of shock event, almost as if it hit glass. That's kind of interesting. Maybe not almost. Yeah, I mean, these octahedrites are the most common of all iron meteorites. They all have this Widmanstatten pattern to them. You slice them up like that.
Do they come in any other geometries, or is it only that? Is it only octahedral?
Only octahedral.
Huh, wow.
And the pattern's going to change the way you slice it. Like if you slice it from the top, it'll give like more of a squarish pattern. That's just the way that, that's the way you slice it. Pretty fascinating stuff. So, I mean, let's see, we got these space rocks.
How is it packing itself? How they organise themselves? How are the crystals organising themselves? They've got to pack fully without leaving no gaps.
Well, you've heard of crystal field theory, right?
No, go through it with me.
Crystal field theory. There's a couple different types, but the main type is octahedral crystal field theory.
Okay, where would I find information on that then?
Google's a good tool.
Just Google. You don't go to recommended sources.
Crystal field theory. I made a video on it. I made a nice little simulation.
Oh, I'm going to have to go through your channel, aren't I? I did have a brief look. At your channel the other day, but I'm addicted to coming here. I haven't really been looking. I've got a list of things I want to look at.
Yeah.
It's when you get the time to actually.
Here's a little animation I did for the crystal field theory.
Yeah, I like your animations.
So you have three cardinal axes, your X, your Y, and your Z, right? And you simply just attach the corners. They call them ligands. They're all negative on the corners. And there's a positive in the middle, cation. And so when those ligands converge toward the center, they react with the positive cation and they create a sphere. And that sphere expands to a bubble, and that actually surrounds the octahedron.
Yeah, but that shape won't pack space. There'll be gaps. It's like trying to put circles on a table and to fill all the table up. You're going to have little like concave triangles, aren't you? You're not going to be able to fill the table. Like you can fill the table with a triangle, equilateral triangle. You can, fill all the space. In three-dimensional space, that octahedron doesn't fill space.
It fills space. What do you mean it doesn't fill space?
I mean, I can't see how the crystal structure works. I can see how how can an individual structure work, but I can't see how that can fill space up. It's going to have gaps. If I try to get 100 of these octahedrons and then try to fit them in a box, there's going to be lots of gaps. They won't fill the space.
Well, that's why they overlap. If you slice up an octahedrite, they call it the laminae. It's overlapping with each other, so it fills the space.
Can you show me that? Have you got an animation of that?
No, I showed you a picture of the Widmanstatten pattern.
Oh, okay, I'm with you. Okay. They overlap each other.
Yeah.
Interesting.
Yeah, so I don't know. I just find it kind of interesting, you know.
With CGI imagery like yours, Stephen, you'll be the next Disney fucking employee.
Well, he did start out poor. Walt.
You'd know all about him, wouldn't you?
I watched a movie about him.
Well, you watched one movie about him. Interesting.
Yeah. Walt before Mickey. Walt before Mickey. These are the d orbitals. That particular orbital, the DZ squared orbital, it has a toroidal inertial plane.
Say that again, please.
Yeah, go back here. This EZ squared orbital has this toroidal inertial plane in the center. That expands out to create our equator. So that's why we have reversal polarities between the north and south hemisphere. We have the doldrums, we have the Hadley, we have the reversal in hurricanes and typhoons.
What? What the fuck is this? It just looks like a weird fucking ball. It looks like a weird fucking like balloon inside a fucking supposed diamond or whatever. Octahedron. Octahedron.
You know the orientation of the electron fields within the octahedron. Specific orbitals.
Doesn't look very pretty. I thought God's like world's a little prettier than what you make out.
They're conformed to.
What?
So that toroidal energy, that dielectric inertial plane of energy is going to expand out like that, and that creates our equator.
Couldn't you made it more pretty? What? It's not pretty enough.
Pretty.
Yeah, I don't understand it. It's not pretty enough.
It's pretty. We got pink.
What?
Pink and gold. Pretty.
That's right, that's pretty.
No, that's me.
So imagine all these octahedrites are just like little fractal pieces of the main octahedron that broke off, probably during the flood.
Just looks like you draw a whole bunch of weird patterns and then like say like, yeah, this is what we live inside. Like I'll draw a fucking diamond and then I'll draw a fucking oval. I'll put them all together and just make random shapes, chuck them all together.
That's the pearl and the oyster. I'm casting the pearls. Some of you are swine.
What happened?
Some of you are swine.
What do you mean you're casting pearls? Where's the pearls?
Well, you know how you find like a pearl and oyster right in the center?
Nah, not really. I don't really eat oysters.
Precious gem, a jewel, precious jewel.
Oysters killed Patrick, so I don't really like things that kill people.
You know, a diamond's base crystal habit is octahedral too. Diamond. I'm sharing a diamond with you guys.
Okay, show me diamond.
You trying what?
Diamond in the sky. Lucy in the sky with diamond. Lucy in the sky. Lucy, Lucifer.
I'd rather you go with shining your crazy diamond, but it's okay.
Lucy in the sky with diamonds. Lucy in the sky with diamonds.
Interesting.
Lucy in the sky with diamonds. There you go.
There you go.